Hi everyone. Today we're going to talk about rational exponents, how to write equivalent expressions, and then how to evaluate them. So the first thing we need to explore is what happens if you have a power to a power. So 4 squared to the third. We've got two exponents going on. So the first step I'm going to do is break it down into 4 squared times 4 squared times 4 squared. Because cubed is a number times itself times itself. And if I expanded this even further, I'd get 6 fours. So I have 4 to the 6th power. So if I see a power raised to a power, I can just do 2 times 3 and get 4 to the 6th. I can take that shortcut. That's one of the properties of exponents. Same thing with x to the 7th squared and 9 to the 5th to the 1/2. Now we're going to see today what happens when we get a fraction in an exponent. What can we do from there? But if I see a power to a power, I multiply. Now some other properties. We just talked about power property, power of a power, and product of powers property. So if I see x squared times x cubed, I can just add those two exponents if I have power times another power. So if I have multiplication, I have addition. If I have division, I have subtraction. And now power of a product property says if I have multiplication to a power, I can do x to the b exponent and y to the b exponent. And same thing with division. Now today we're going to add more properties. What if you have x with an exponent of m divided by n? We can say that m divided by n is really m times 1 over n. So we could do x to the m power, and then n would be a root. Like we saw in previous lessons, if we have 1 over a number, that's the nth root. So what we're going to see is that if we have x to the 2/3 power, we have x squared and we have the cube root. So we have the cube root and we have x squared. We're going to be able to evaluate expressions this way. So here's our example problem, 64 to the 2/3 power without using a calculator. Step 1 is I'm going to write it as a root and a power. So I have the cube root because I have divide by 3, and I have squared because I have the 2 in the numerator of the fraction. The cube root of 64 is 4. 4 cubed is 64. We're going to keep practicing. You're going to see certain numbers show up over and over again. So we're left with 4 squared. 4 squared is 16. Now that's the way I would do it. The other way we can look at it is we can square 64 first and get 4,096 and take the cube root of 4,096 and still get the same answer of 16. I recommend taking the root first, getting a small number, and then do the small number to a power, especially if we don't have a calculator. Some other theorems that come from this: anything to the 0 power is 1. And if we have a negative exponent, we can put it in the denominator. So negative exponent does not mean that it gets you a negative answer. It just means that the n power is in the denominator. And these both come from proofs that I can show at office hours. Now, what happens if we have a decimal in the exponent? What do? We haven't talked about any rules using decimals, so if I had a fraction, I'd be much happier. So 1.25, we convert the decimal to an improper fraction. 1.25 is 1 1/4. Mixed numbers terrify me, so I like improper fractions, and I have 16 to the 5/4 power. And we're going to follow similar rules where we take the 4th root of 16 and raise it to the 5th power. 4th root of 16 is 2. We're left with 2 to the 5th power, and that gets us 32. So when you see fractions in the exponent, rational numbers in the exponent means there's a root and a power. So it's two parts in one. We got to do one part at a time. So always write it as a root and a power, and then go from there. And that's how you evaluate rational exponents.